Hello, everybody, and welcome to today's expert talk. I am Philipp, but I'm just for the moderation here, and our main guest is Christian. So hi and welcome, Christian. Well, one of the most requested and important features of for our enterprise clients is single sign-on. Of course, everybody wants to implement single sign-on to just make everything much more convenient to use and, of course, more secure. However, Boxcryptor is a zero-knowledge service. It wasn't easy to implement a feature like single sign-on when you are a zero-knowledge service. So in today's expert talk, our head of security, Christian Olbrich, will give you an in-depth presentation of our single sign-on functionality with zero knowledge and how we were able to develop it. If you have any questions during the presentation, please use the Q&A functionality or the chat, and we will do our best to answer all of your questions during or after the presentation. And of course, the session will be made available as a record too, probably on YouTube. So Christian, the stage is yours, and have fun.
Okay, thank you, Philipp. Let's see if I can get you to see my screen. All right. So if everything worked, then you should see something now. Welcome everyone from my side as well. My name is Christian, and we've got something special for you today. As Philipp already mentioned, we are going to look at zero knowledge in an SSO context, or more specific, how we were able to implement and offer single sign-on in Boxcryptor while still maintaining the zero knowledge component. So this is something that we usually present one-on-one in our setup talks, and it is actually worth talking a little bit deeper about it because after all, it's your files security at stake. So before we can start, a little introduction how Boxcryptor usually works without SSO, and this will really be quick. We've got the Boxcryptor server, mainly used to distribute keys, especially public keys, and we've got Boxcryptor client. And everything, of course, starts off with the user's password. And we need access to the Boxcryptor server, so we need some kind of authentication. And we're doing this by sending a fingerprint, a so-called hash, to the Boxcryptor server. This allows us to make sure that we authenticate the user while not actually getting to know the password. So you can calculate a hash from the password, but you can't reverse calculate that. If that works out, then you're getting a Boxcryptor token. And from the password itself, we can calculate an initial key. And this initial key is used at the start of the chain to decrypt everything else, especially the private key of the user. And from that, the chain goes on to finally decrypt the files. So we have Boxcryptor server access, and we've got the initial key. So far, so good. Now let's have a look how things change when we add single sign-on to the mix. What we've got now is an identity provider. And when kicking in the SAML authentication, then the client doesn't get the password any longer, but actually just the identity provider is getting the password. And the identity provider would then return an assertion over the Boxcryptor client as a relaying party to the Boxcryptor server. And the Boxcryptor server would note that the assertion is signed by the identity provider and that it is the user that he's saying to be, and would return the Boxcryptor token. So we would have Boxcryptor server access, but now we're missing the initial key, the one that we usually create from the password. By the way, I'll simplify this procedure a little bit to make the graphics a little easier to understand. So I'm cutting out the relaying party, and I'm just sketching this as a communication between the Boxcryptor server and identity provider. When it says SAML, then it's obviously always over the Boxcryptor client. So we need a new component, and we need this new component to have a replacement for this initial key for the password. And this is where the key management service comes in. There are several offered. Azure offers one, Amazon, Telekom, especially for German speaking customers, and HashiCorp Vault is a on-premise solution. And this key management service generates, distributes, and maintains cryptographic keys. So it's basically cryptography as a service. And this offers a replacement for the password-based initial key. What is important here is, of course, that if it keeps control of the initial key, then it cannot be a component that is actually controlled by us, by the SCIM bar. It actually needs to be controlled by the company itself. This can actually be viewed as an advantage, so you get more control about your keys and especially about this very important initial key. So this component fits into the company-owned realm, and the process would now look as follows. We need an authentication to the key management service. Let's just assume for a second this is not yet the final solution, that the Boxcryptor service serves this KMS token for the access to the key management service and serves an encrypted initial key. The Boxcryptor client would then be able to forward that request to the key management service. The KMS token would authenticate it, and it would then be able to decrypt the initial key, return it, and from that on we could decrypt the user's private key and the complete keychain. And this works. We got Boxcryptor server access, and we got an initial key. I've left out all the stuff that we did before with authentication to make the graphic a little easier to understand. The problem, of course, is that this is absolutely unsafe, because the credentials, the KMS token used to decrypt the initial key, is also known in this model for the Boxcryptor server itself. So nothing is keeping the Boxcryptor server from issuing that request to the key management service directly and simply decrypting the keychain itself. So you could argue that you could make some infrastructure security measurements, for example, that you restrict the IPs that can access the key management service, but this is actually just hacking around the real issue and is not a sophisticated way to ensure single sign-on. So we need an additional component, and actually this is the final component that we need for this. This is a small stateless server that we provide, and it's called the Boxcryptor crypto server. This crypto server has mainly the task of a bouncer. So it proxies the access to the KMS and only allows authorized entities in. How this works in practice, we'll see in a second. It also gives us a few additional advantages. For example, with Boxcryptor crypto server, we can actually allow user and group provisioning and management through SCIM. More on the later as well. And as a small additional advantage even more, it can even make your setup cheaper by being a singular KMS client. For example, some KMS are licensed by clients. And if you have a lot of Boxcryptor clients, then normally each of these clients would need an actual license. And in that model, the Boxcryptor crypto server will be the only instance talking to the KMS, and therefore you can go with only one license. So we get that component in the company-owned realm as well. The key management service is now a little more in the back, and we can actually make this physical as well. We can add a firewall between that, because the only entity able to or necessary to speak with the key management service is now the Boxcryptor crypto server. So how does authentication look now? So when the Boxcryptor client authenticated via SAML, then we are just returning the encrypted initial key. So no credentials whatsoever to authenticate to the Boxcryptor crypto server. That will actually be done by the client itself again. We are forwarding that request to the Boxcryptor crypto server, And the Boxcryptor crypto server now issues a second SAML authentication. So we're actually not having one authentication anymore. We're actually having two authentications. And you might think that this would provide for some odd user experience. In actuality, it's transparent to the user because you've got the first authentication already through, you got the cookie, you are already authenticated. And the second authentication just runs on the cookie and the user doesn't even realize he actually signed in twice. After that, the Boxcryptor crypto server knows that the user is who he is supposed to be, or better, that he has the rights to access the key management service. He forwards the encrypted initial key to the KMS. That one can decrypt it, and we can forward that initial key back to the client. And from that on, we can just go the normal road and decrypt the remaining keychain for the user. And once again, we got Boxcryptor server access and the initial key. Now, let's have a closer look at the security of this construct. So if you take a look at the Boxcryptor server cannot decrypt the initial key because it simply isn't granted access to the Boxcryptor crypto server. So it could obviously speak to the crypto server, but the crypto server would refuse forwarding any encrypted key and actually decrypting that key because the Boxcryptor server doesn't have an authentication on the identity provider and is not authorized to make that request. We've got the key management service, and the key management service, while holding all the initial keys of the users, never gets the keychain to actually use it. So the all-important part of this picture is the user's private key, or the group's private key for that matter. And this is never forwarded to either the crypto server or the key management service. Same goes for the crypto server. It never obtains an actually useful key for decryption, just so to say, password key replacement. And there's a little additional feature, and that is not so much absolutely required, but it's a nice to have. And this is actually the double authentication. So you could argue that you could do the authentication just through the Boxcryptor crypto server, and the crypto server can then create a signed token for the Boxcryptor server to say, well, he's authenticated, it's all right, he may access the keys. If we would do so, then we would give the crypto server too much power, because at that point, the crypto server would become a single point of failure. And if that component would get compromised, then the attacker would have all the means to decrypt the complete keychain of the user, and with that, of course, also the files. We got the Boxcryptor client, and the client is like every client in the way that he only receives the user's keys. So if the client would get compromised, then really only that singular user is compromised, and not the whole architecture and all the other users. This leaves us with the identity provider, and we managed to reduce the single point of failure to really just the identity provider. And it's quite obvious why that is that way, because the identity provider obviously defines who is who. And if you can really select which password the users should use and create new users and all that, then you can obviously take over any user's account. All right, let's see how this goes for new and existing users. Let's say we're dealing with a new user. Once again, I've left out all the components that won't take part or that are not too important in this picture. The user kicks in a SAML authentication, and the identity provider returns a user that is not yet known to the Boxcryptor server. At the server, we can create that user, but obviously we cannot create the keys, because the keys have to be created on the client, or in this case on the Boxcryptor crypto server. So what we do is we forward a request, pretty much saying, please create some user keys for me. The Boxcryptor client does this, and the initial key is now forwarded to the crypto server, and the crypto server is sending the encrypted counterpart back. And at that point, we can provide the Boxcryptor server with the complete encrypted initial key set, all the keys, all the keychain, and Boxcryptor server can store it and deliver it when that user signs in at another time as well. It's very similar if we're dealing with a user that is known to Boxcryptor, but that is not actually marked as a single sign-on user. So in this case, we would get a assertion about a user that is already there, but that is not yet integrated in single sign-on. And I have to say at this point that we only continue the path that I will show you when this is actually a setting for the company. So you can just take any identity provider and start making regular users part of your domain. So what we're now issuing is we're asking the client to re-encrypt the user keys. Because the user has already worked with Boxcryptor, so he might already have some files encrypted with it that he obviously shouldn't lose. And for that reason, we can't just create new keys. We have to work with the old keys and just make them available to single sign-on. The first step in this process is, of course, we need the old password. So the client asks for the old password, is then able to decrypt the keychain, and then proceeds as if a new user would be created. So we're creating an initial key as a replacement for the password key. We are encrypting it through the Boxcryptor crypto server, and then we're able to upload the complete keychain again with the encrypted initial key and all the other keys as well. All right, so let's go one step forward and look at SCIM integration. So our big limitation for single sign-on so far is that the information flow is really one way. That means that the Boxcryptor server really only knows about or gets to know about a user, a new user, or a group, or better, in this case, even only a user, if that user tries to sign in. And this has some serious implications. For example, the user, when he hasn't signed in yet, is not known to Boxcryptor, and you can only start sharing with that user after he signed in at least once. Groups are completely out of the picture because groups are not forwarded with the regular SSO flow over SAML. So SCIM comes as a solution for that, and SCIM is a system for cross-domain identity management. And it's pretty much auto-provisioning. So this below is just a quote from Wikipedia, a standard for automating the exchange of user identity information between identity domains or IT systems. So what we are doing now, or what we can do now, what we offer, is that the identity provider can issue requests to create users, groups, or group memberships. So this is basically a synchronization request. The Boxcryptor server can forward that request to the crypto server, and it authenticates itself with a JWT signed by the Boxcryptor server, and of course with the destination of the crypto server instance. And the Boxcryptor crypto server can fulfill that request because it can actually create the keys necessary and return the encrypted keys, key sets to the Boxcryptor server. Now hold on a minute. That does sound a bit dangerous. So the Boxcryptor server can actually create users, groups, and even group memberships. It can, but it's still safe. So you have to be a bit careful. So it needs some well thought through designing, but it can actually be done to still keep the zero knowledge claims. So for that, we have to look at the singular entities. For one, we've got user keys. And if we're thinking as an attacker, then what could the Boxcryptor server do? The Boxcryptor server could create a company user, or better, it could create keys for a company user. The issue from the view of the attacker, of course, is that this would be completely useless. We would have keys that we cannot decrypt because we are only getting a key set from the crypto server and not actually any starting point to decrypt these keys. And the user would also be invisible to the IDP itself or to the company itself, because it's not a user actually existing in the IP. So we would have kind of a ghost user, and that couldn't really do anything or decrypt anything, and is therefore not a security issue at all. And then we've got groups, and groups are cryptographically actually equivalent to users. So we might create a group, and this group could even be used by the company, but we still wouldn't be able to actually access any keys of the group because the crypto server would have created them and just sent us the encrypted counterparts. It gets more interesting when we look at group memberships. So this is a little extra here. So how does the structures, how does do the objects of users and groups and the relationship actually look like? We've got users, we've got the all-important private RSA key, and obviously its public key counterpart. And this private RSA key is encrypted on the user side with his initial key. The group is very similar. It also has a private RSA key, public RSA key, and the private key is again encrypted with the initial key. Now, for the user side, the initial key is either the password key of the user, or in a single sign-on context, the initial key that is created by the, or better, that is encrypted by the crypto server. These have a relation through a group membership, and we've always got one user can have several group memberships, and one group can also be part of several group memberships. And this group membership simply has the group's initial key encrypted with the user's public RSA key. So what the user can do is he can use his private key after he has decrypted it, and he can with that decrypt the group initial key, and with that group initial key he can then access the private RSA key of the group and continue with decrypting any files that are encrypted for that group. So for group memberships, let's look at a attack scenario. So the Boxcryptor server could create a non-SSO user, and for non-SSO user, this is just a regular user. Of course, we can create one for us self that we can then also decrypt. Then we could instruct the crypto server to add this user to an existing company group. And in that case, the Boxcryptor server could decrypt the non-SSO users keys, and this user can then decrypt the company group keys. And to prevent that, we have another safeguard in there. And the safeguard is that the crypto server only accepts requests with key sets that it created itself. So if we are issuing a membership request, then we are not only sending the according user and the group ID, we're actually sending the whole encrypted user. And the crypto server is then looking if he can decrypt that user, and if he can, then it's a given that the crypto server actually created it. So we can smuggle in a user that is not in the company into a company group. So we've got some additional safeguards as well. This is for one, the mutual exclusive access rights. So we've got 2 points of contact pretty much. We've got the client endpoint. This one is SAML authenticated, and the client is only allowed to encrypt and decrypt the initial key that he gets. He cannot actually create any groups, users, or even memberships. Then we've got the Boxcryptor server endpoint, and this one is authenticated by the Boxcryptor server signature. And the server in turn can only create groups, users, and memberships, but cannot actually decrypt anything. And exactly, and requests are only processed, the server requests are only processed when they come directly, when the components of it came directly from the crypto server in the first place. So we can't smuggle any entities in there that are not actually company owned. All right, that would be my part of the presentation. I'm very much looking forward to your questions.
Oh, Christian, we do have a few questions, or 2 questions. If anybody else has questions, please use the Q&A functionality or the chat. So the first question, Christian, is about the Boxcryptor crypto server and about the availability. Does the crypto server requires high availability, and what happens if it is not accessible?
That is a very good question. So the Boxcryptor crypto server is actually a very convenient server. So it's, for one, it's stateless. So you don't have to worry about losing any data. Let me quickly stop sharing this. You don't have to worry about losing any data if one server goes down. We also recommend using 2 instances instead of 1 instance, so that also gives you some redundancy. And as for the availability, you need it once to sign in. So once you've signed in, the client actually caches his initial key and is then able to work from that. So you can, for example, go offline and still continue working with Boxcryptor. If the Boxcryptor server or the Boxcryptor crypto server is for some reason not available, then it's not a complete catastrophe. You can still work with your files.
Thank you. And Christian, well, this isn't a question that was posted, but this is a question people very often ask. Maybe if you extend the answer, not just related to the Boxcryptor crypto server, but basically to everything we provide. So as Boxcryptor is software as a service, what is the implication of when, for example, Boxcryptor, the company behind Boxcryptor, goes out of business? Do they lose all their access to encrypted files, or what is what happens if we go offline?
That is another very good question, and yes, it does come up every once in a while. So obviously, just making sure that any hackers don't access your data is a good goal, but it's not sufficient. You also have to make sure that you can always access your data. And we have several measures to actually make sure that this is the case. We've got, from one standpoint, we've got a mechanism to export keys. So you can always export pretty much what is Boxcryptor's database about your company. And with that and a client, you can always access all your files, even if no Boxcryptor server should be available anymore. Then we have the additional advantage of the key management system on the client side. So you even have your initial keys, your most important keys readily available. This also makes the process if a user forgets his password much easier. All you have to do is to change the password on the IDP and not go through any trouble with any resets or any master key decryption, which is basically the key export functionality that we have.
Thanks. Okay, well, next one I think is a tricky question. You mentioned that the identity provider is the single point of failure. Is this something we simply have to live with, or are there any recommendations to improve the security of the identity provider?
Well, in this case, it's just normal infrastructure security measurements. So we do have a single point of failure. At some point, you can, of course, do something like two-factor authentication, though this is generally also done on the identity provider. So if you're really talking about a compromised identity provider, then this does not help you too much. So this is just a point of failure with which we have to live.
Okay. And well, this is the last question, but if anybody else has more questions, please use the Q&A or the chat once again. It's more like an infrastructure question. Is the single sign-on setup available on premise, and can we set it up on our company's infrastructure?
Yes, we can. This is HashiCorp Key Vault solution, and we have this very conveniently bundled. So we have it's actually bundled into a Docker image with our crypto server. So if you have a existing setup with HashiCorp Vault, then you can obviously just use that. But if you want a no trouble solution, then you can just go with the instance that is bundled into the Docker image with the crypto server. And then you have very little work to maintain this, to set it up, and it just pretty much works out of the box.
And maybe to just give some input from the sales team. So we always get, or sometimes we get requests from public companies or from the public sector. They're asking if it's possible to run Boxcryptor purely on premise. As Christian mentioned, we are able to do the single sign-on setup on premise. However, Boxcryptor is designed to be software as a service with zero knowledge. But if you want to share encrypted files with people outside of your organization or manage permissions with users from different Boxcryptor organizations, this is where the software as a service comes in play. Okay. And I posted the link to HashiCorp Vault in the chat for you all, and you can check it out. So we really like to work with them. Okay. Oh, wow. And another question came in. Christian, with state actors having huge resources, server in the middle attack could dupe the whole network and get new keys that are valid. Any verification on authenticity of server periodically?
Could you post the question again in the chat for me? That was
yes, I will post it again in the chat. It's a little longer.
Quite a complex question. Well, of course, all the server components are talking over HTTPS. So we are assuming in this case that the communication channels are actually secure. So if you're breaking into HTTPS, then let me quickly think about it. Then obviously you can get all the information that the client is getting, and then you would have all the tools to decrypt the data as well. So that is just something that we assume as a given, that HTTPS is actually working and secure.
Okay. Hopefully this question is now answered. If not, you can just use it again. Okay, I would say we wait maybe 1 more minute for another question or another questions. But as said before, the whole presentation will be made available probably on YouTube, and we will send you one follow-up email, just send you the link over, probably on Thursday or Friday. Christian, thanks a lot for giving us the presentation. Thanks a lot for taking your time and for answering all the questions.
Of course, thank you.
Okay. So thank you, everybody, and hopefully you have a good week and a good day. Thank you, everybody. Bye-bye.
Bye-bye.